Okay, this is the exercise I wanted you to do, right? You must start your program with these two statements, and then you do whatever this says you must do. So, Brandon, you want to share. So I'm going to stop sharing mine, and you can share now. Okay, let's see. Yes, those are the two. I like your formatting, very good. And you had great inline, end of line comments. Okay, so first okay, Brandon, I will let you talk. Explain your code.
So the example you gave us, the numbers were in quotes, so I put them in quotes, but that would put them as a string. So I had those input, and then I converted them and stored them in, converted them to integers and stored them in a separate variable, and then printed it out. Since it was already a string, I didn't need to convert it back. I just had to use the first variables. But then for the mathematical operations, I used the variables I had set with those numbers as integers, and then just let it do the calculations that were needed.
Okay, so why did you use the str in front of each expression?
To convert the result into a string for displaying.
Yes, yes, very good, excellent work. And you explained it very well. Thank you, Brandon. Let's leave it here for a little while, for 1 minute or 30 seconds, so that everybody can have a look. And everybody, you know, if you want to take a screenshot, you can take a photo, you can, right? This is how you learn. You look at other people's code and look at it and learn it. So, okay.
Can you enlarge it, Brendan?
I just kind of skipped the step of
Okay.
Yeah, making it equal to 450 immediately. Let me see. I might need to.
Okay, let's talk about this. Let's talk about this, Justin. Thank you for making this large. I can see it so well. Okay, remember what I said. I want this must be a string. Okay, you cannot immediately convert it. You must start it with those two statements. Imagine that those are from the user, right? So you don't know it's 450. You don't know it's 567. It might be something else. So I'm giving you those two statements to simulate actually the user input, right? Okay. So you cannot immediately do this because this you are putting a hot number there. Then what if the user input is different? Other than that, okay. So, and also I would make, and Justin, thank you, but I will make a suggestion that you don't want to call this strnum when it's an int. Mm-hmm. You will call it intnum to avoid confusion, right? This way, when I say strnum1, it's implicating that this variable is storing a string. So this way you can look at the variable immediately, you know what type it is. So you would, if you do this, you want to change the name to something else.
Okay.
Okay. Like Brandon, just the first one, Brandon's, you know, you can convert this into, let me just silence my phone. I forgot to do that. Okay, so you can say num1 equals to int string num1, right? Mm-hmm. That would be a better solution. And you had excellent formatting also here. You had the author's beginning at the beginning of the program, and you had the comments. Very good. And division, okay, about round, right? About round. Yes, this is very good. You are using that function. And sometimes you may want to keep it as is, because once you round, you're losing the precision. Mm-hmm. But you're right. When you round it, when you output it, it looks very good. But this is, I would say, this is a little bit more deeper. You haven't learned this yet, but this might be better when you output it. When you actually do the division, you don't
Mhm.
round it, right?
Okay.
You want the value to be precise, but when you display it, you can display it with 2 decimal places. But when you calculate, suppose you are using division in another expression, you want to do calculation, then that is still the precise result. But
Okay.
when you display it, you can round it. Does that make sense, Justin?
Yes. Yes, that
Okay.
makes sense.
Yes, good. Okay. Quotient, that's very good. Remainder, very, very good. And oh, yes, you converted them into int. You see, here is where I look at this, I think, oh, that's a string. You cannot do that. But actually, you converted them there. And that's the reason I'm saying you
Mhm.
want to make sure your variable represent the type, right? If you
Gotcha.
call it num, you will automatically think this is a number. But if you put str in front of it, automatically you think this must be a string. So you always have that danger when you have a variable name that doesn't tell its type. Thank you so much, Justin, for displaying this, for sharing this. And I'm using yours as a teaching material, as some teaching materials to tell everybody about the things. So thank you very much. And this is great. It's
Oh,
very,
sorry.
very good, Justin.
Thank you.
Sorry, not Justin.
Mhm.
Not Justin.
It
Why
was
did I?
Justin. Yeah.
Yes, Justin. Okay. Okay. Anyone else?
I
So
divide
let's look at this. Okay. You all did the comments. That's very good. I really like this. 3 of you all did the comments. Okay. Caitlin, scroll up. I don't see the first 2 statements. Okay, good, good. Okay, so those are there. Yes, this is correct too. This is very good too. Okay, Caitlin, I will let you explain it.
Yeah, so I put down the inputs, and then I turned them into integers and did the equations. Then I printed them out, and then with the extra time we had, I decided to divide the numbers again, except doing the first string instead of the second. The second string instead of first.
Okay, you just reverse the order, right?
Yep.
Okay, okay. Okay, everybody. So this is another version of how you do it. If you look at this, the difference between, Caitlin, talk about the difference between this one and the previous 2 versions, Justin's and Brandon's. What's the difference?
Right. So I used the uh, what is it called? I
Conversion?
used the I decided to print it all at once and to have
Oh.
the strings be printed out on a
Mm.
new line using the backspace N.
Okay.
Spacing the name, but
Okay, that's good. There is another big difference with from between what you did and the previous 2 versions.
oh yeah, I also decided to put the equations into variables. Wait.
Okay. I think Brandon did this too. But the big difference is you, instead of converting string num1, str num2 into 2 integer variables at the beginning, you are converting them in your expression.
Oh yeah, yeah.
Right? Okay.
Mm-hmm.
So the other 2 versions from Brandon and Justin are, for example, they said num1 equals to int string num1. Num2 equals to int string num2. And then when they did the division, quotient, and remainder, they will simply do num1 divided by num2, num1 modulus num2, etc. What you did is you are converting that string in your expression. Does that make sense?
Yeah.
Yes. Okay. So this works also, everybody, right? Now, is this good? People have different preferences. If you look at this, so what you are doing is every time you do an expression, you are converting it to an int every time. So since you need to convert it multiple times, why not just convert it once, right? Convert it once and then use it. So that's my only critique. But this is great because it shows that you can do it this way also. You can convert it in your expression instead of converting it separately. And this is great. Thank you so much, Caitlin.
You're
Very,
welcome.
very good. And yes, and Caitlin did the new line, you utilize the new line character in this sentence. Oh, let's run it. We forgot to run it. I think we forgot to run Justin's also. Yes, very good. Yes, the quotient is 0, the remainder. Okay, okay, very good, very good. Thank you.
You're welcome.
We already discussed this, using functions and modules. So let me ask you, what is a module?
A module isn't it like a bunch of like it's a whole bunch of functions or all together. So you can import, for example, the math module, which will have like a bunch of variables and functions that are already programmed in there, built into the.
Yes, that's correct. So what? Why do you put these functions together? Why do you put these functions together, Justin? Do you think?
Just so like I'd say probably for like convenience and because they're all related in some way. So like
yes, they are related. Yes, they are related in purposes. That means they have similar purposes. Yes. Okay. So it's a group of functions with similar purposes. And organizing, you're basically organizing it, right, to make it easily findable. Is that searchable? You can find it easily. Okay. So to call a function, we already discussed this, and we are just reviewing really. And Justin is a master of using the round function. You use it this time, and last time I remember you use it also. So now you're completely proficient with this function. Okay, so round and the function, always remember. So I will ask you, a function is a name, right? So if you look at this round, this is a name. This is a name. And it must have the parentheses. Within the parentheses, this is called argument. Sometimes it's called parameter argument, okay? And it can have none, it can have no argument. It also can have one or more arguments. Okay, so here it has one argument. If you have two arguments, you separate them with a comma, right? So this is called the argument. Sometimes a function has no arguments. So if it has no arguments, when you use it, you still have to have the parentheses. So after a function name, you must have the parentheses. That's very important to remember. Okay, we discussed this help. So here, if you look at this, okay, this round function, its argument, what data type is this, everybody? Do you think? What's the data type?
Float.
Float, right? So round, this is round. You don't have this. Okay, I'm just giving you an example. So of a round function accepts a float and an int. Okay, so a round function, you have two versions. One version of round accepts one argument, which is a float, and another version is it accepts a float and an int, and this int is the decimal places. So you cannot have a float there. A decimal places, it's just the number of decimal places. So it's an int. Okay, so this version of round accepts a float and an int. And look at this help. This is a function, right? Help is the name of the function and the argument. How many arguments are there? Everybody? How many arguments are there?
One.
One.
1. And this is actually not a string, not anything. It's a function name. So this is a special case. Okay, let's look at this. Functions like these, we already said these are within the built-in module. You do not have to import them. But any function in the math module, you have to import them in order to, you have to import the math module in order to use it. And how do you import? You import, this is importing the math module, the whole module. Okay, after you import it, you must use the math, you must preceding the function by the math dot syntax. So once you import math, you can do math.py. That will give you pi. Math.square root. This is a number, right? That's one argument, and that's a float, and it will give you the square root of that number. So let me ask you this. We discussed this last time, so we are really reviewing. Math.square root 2. What does this give you back? What type of data does it give you back? And to use the jargon in programming, we say it returns a value, right? It returns a value. What type of value does it return?
A float?
A float, yes. Okay, a float. So remember, these functions all return a value. Okay, now this syntax means you import only those two functions. And because you specified those two function names, when you use them, you do not have to use math dot. You can use the not function. This is a constant. It's not a function. You can use it directly without the preceding math dot. Okay, so we discussed that also last time, and I showed you examples. And once again, I misspoke just now. This is not a function. This is called a constant. It's a value. Okay, so math.py is a value, not a function. Because you see, there is no, because it's a value, you don't have the parentheses after it. Okay, that's important to distinguish. Any questions about this? Now let me ask you this question. Do you think this print, okay, let's see, how many arguments are there for this print?
2.
2, yes, 2. You separate them with a comma, 2 arguments, very good. And does print return anything? That's a hard question. Does print return anything?
Yes.
No, print doesn't return anything. It immediately executes and display the result on the screen. It doesn't give the program back anything. That's the difference. And gradually you will understand that. Okay. So here, if you say, you may import all of the module's resources to use without the qualifier. If you do this, you can, okay, here, right? This is all the functions. From math, import all functions. And now you can really just say square root 2.5 or something without math, because you already imported all functions instead of specifying not only functions. That's why here it says resources, so including constants, right? So this is importing all of them. This is importing just 2 of them, and the syntax is the same, from math import. Okay, the recommended way is to import the whole module and then use the module name followed by the dot, followed by the function name or constant name. So this is really the recommended way of doing this. Kyle was in traffic just now. We just pretend that we are on campus doing a face-to-face class. So Because of the rain, traffic was jammed and Kyle came in late. Okay, so we import math, the module, and then you precede the constant or function name by math. The benefit of this is that you immediately know which one it is, which module it belongs to. Because sometimes you use function, you can write your own functions, and we will do that in chapter 5. So if you don't distinguish them, then you don't know which function this is. You don't know if it's from a module or if it is self-written. Does that make sense, everybody? Okay.
It does.
It does. You will be able to write your own functions, and we will learn how to do that in chapter 5. So you can use your own functions because you wrote it right there, right? You don't have to precede the package name, the module name. And then if you don't do this, if you use the math functions this way, and then you have your own functions, you don't know where that function comes from. It becomes confusing gradually. So that's why this is a recommended way. Okay, always precede your function with that module name. That's preferable. A lot of times students ask me, what do you prefer? Sometimes I would say it's really your own preference. It doesn't matter what I prefer. But here, it's not that I prefer, it's good for you. So you will use this way to make your code easier to read and easier to debug, okay? So we discussed this already last time, and I remember I wrote this, right? I'm putting it here. I wrote this as an example so that you know how to write your program, okay? Okay, now let's look at the exercises in the book. I don't remember. Oh, we can go to the, let's go to the book, right? Recording. Okay, so this is page 59. And input, please press enter or return to quit the program. So here, everybody, what's the function name?
Input.
Input, yes, that's a function. That's the function name. How many arguments are there?
One.
Just one.
One. What's the data type of the argument?
String.
Very good, very good. Okay, so now you know input is, we talked about this, but now you may understand it a little bit more better. That means input is a function and it accepts one argument, which is a string, okay? Okay, so let's look at these exercises. Explain the relationship between a function and its arguments. What's the relationship? It's a little bit difficult to explain, actually, I would say. So can you explain?
The function determines the data type of the arguments. So for example, if it's print, then it's not going to return like an int or some, or like a number or something like that. It's just going to return like a string or something like that, depending on what the function is.
Okay, okay, good. Anyone else? Thank you, Justin. Anyone else?
Function is like a set of instructions on what the program wants to do, and then the arguments tell that function like what to do, whatever it's programmed to do with. So like
Yes, yes.
use the arguments to. Yeah.
That's a very important preposition, to do with. Yes, yes. So a function is just a name, and behind that name, it's a bunch of code. It's instructions. So it's a group of instructions that will accomplish a task. And when you call a function, when you use a function, you are actually using that group of instructions. So that name is just an abstract name representing that group of instructions. So it will accomplish a task. And an argument is what that group of instructions will work on. So like if you want me to grade your assignment, if you say grade assignment, right? this grade assignment, this function, the instruction will be review the assignment, look at the rubrics, and look at each line of code and see if it's correct and run it and see the output. You know, that's the instructions. So when you say grade assignment, that's the instructions behind the scenes, right? The detailed steps. But if you ask, you let me grade your assignment, there must be an argument. That is your assignment, right? So I will work on your assignment. The instructions will work on your assignment. Your assignment, the submitted assignment, is the argument, and grade assignment will be the function name. So yes, that's the relationship. The argument is the value that the instructions will work on or work with, okay? The math module includes a power function that raises a number to a given power. The first argument is a number, and the second argument is the exponent. Write a code segment that imports this function and calls it to print the values that and that. So I will let you work on this. I will give you 5 minutes. Do you think that's enough, everybody? Do you want 5 or 10? 5 then, okay. I will let you write this, okay. So you will print out the value of 8 raised to the power of 2 and 5 raised to the power of 4 using the math function, which is called pow, okay. Let's do that. I will come back. We will resume at 10:45 then. Yes, this is correct. Very good, Omkar, thank you. Okay, anyone else who wants to share?
I'll share.
Okay, Justin, let's look at yours.
It says he's still sharing.
Okay, from math import POW, num1 is yes, yes, yes. Very good, very good. Let's run it.
Whenever it pops up.
Okay. Yes, yes, very, very good. Very good. This is very informative. Is it my house, the fire alarm? Yeah, this is very informative, everybody.
Sorry.
If you look at that, that's okay, right? When you output, you always want to be informative so that the user knows what he or she is looking at. Otherwise, they don't know, just 2 numbers. What are those 2 numbers, right? You want to be more informative. Very, very good. Okay, everybody, let's go on. So that's that question. Explain how to display a directory of all of the functions in a given module. How do you display a directory of all of the functions in a given module? You know, I will let you read this and then I will, okay, let's see. Do I have it? I don't have it. I don't have it. Okay. So I didn't tell you how to do that. Okay. So anyone who knows how to do that, I will let you. This is how you do it. I will do it, everybody. I didn't tell you, and we haven't learned this. So, okay, this is what you do. You have to import that module, and then you can list the everything in the module. Some of you are in the network classes. How do you list the directory? You know that. What is the keyword?
EIR.
Yes, yes.
And then
okay.
That's what I put in it.
And then it will give you all the functions. If you look at this, right? You look at all the functions, square root, sine, sine, cosine, tangent, etc. So power, right?
I don't think we can see your screen.
Oh, you cannot see my screen. Okay, let me share my screen. Okay, so if you look at first, you have to import math. So that module is available to you. And then you say, okay, give me all the functions in that module directory. That is a DOS command, a network, a Linux command, a Unix command, and the network people know that. So directory, that gives you everything in that directory, in that module, okay? And then if you want to know, how do I use 10? You will do help, and then 10, right? Oh, it is there, right? So, okay, let's do help. How? So I see it is there, did I? Well, anyway, if you do POW, it shows you, right? So base exponent, it can accept at most 3 arguments, right? So some types, such as ints, are able to use a more efficient algorithm when invoked using the 3-argument form. So basically, when we use it, most likely we use just those 2 arguments. We don't have to have this. And that's what I told you. When you see something is equals to none, that means it's optional. The 3rd argument is optional. So this allows you to see how to use a function, right? Help square root. I really have no idea why it does that.
You would have to do math.tan or math.square root.
Why? Why don't I have to do? Oh, okay. No, power is a math function also, is it? No? Okay, let's see. Yeah, math dot. You're right. But I'm who said that just now?
Since we imported POW individually for an earlier exercise, I think POW
You
was
think?
already in there on its own.
But I didn't. This is a new shell. You see, I never imported POW by itself. Anyway, that's something that I have no explanation right now, everybody. Thank you, Brandon. I have no explanation right now. So I will look into it. Why does this work, right? But this doesn't work. I don't know. Math.10. You see, this works. So I don't know. I will look into that, everybody. But just know that if you want to see how a function is used, import the whole module. You see, I imported math, right? I never imported the functions individually in this shell. So this is a new shell. Okay, if it doesn't work this way, use this way, right? One way or another, you will get it done. Any questions? Okay, let's look at the last one. Explain how to display help information on a particular function in a given module. We just did that. So we are finished with that. You know what? We are actually really finished with this chapter. Let's go to the review questions. Let's look at the review questions. This is on page 61. Am I recording? Yes, okay, 61. Okay, let's look at these questions and just to review this chapter. Hopefully, sometimes their questions are not, it's not a comprehensive set of all the questions, but at least we can go back to review the concepts, okay? It's really scary outside, right? It makes you feel comfortable and cozy and feel lucky that we are inside. Okay, what does a programmer do during the analysis phase of software development? Codes the program in a particular programming language, writes the algorithms for solving problems, decides what. Okay, so you gave me the answer. What do you think?
C.
C, why?
Because you're just analyzing the problem. You're not necessarily doing anything yet. You know, you're just trying to figure out how to solve it.
Yes, yes, yes. Exactly. You are not coding. Coding comes after analysis. We said this before. You have to understand what the problem is. Without understanding the problem, you are doing work blindlessly, right? Blindly, not blindlessly, blindly. You don't know what you are doing, what the customer is asking. Okay, good. So it should be C. What must a programmer use to test a program?
Would it be D?
Justin, what did you say?
Would it be? I'm kind of in between either C or D, but I'm leaning towards D.
Okay. Okay. Anyone else? Michael, what do you say?
I would think it would be A or B because, well, not all, but quite a bit would be acceptable for me personally. But
So you will say A or B, but you have to choose only one.
A?
A, all possible sets of legitimate inputs. Okay. Yang, what do you say?
Well, I said B. I don't know.
You say
Like they
B,
all look
you say
pretty.
all possible sets of inputs.
Yeah.
You say B. Okay. Okay. Terrence, what do you say?
I was kind of thinking D. I don't know. Maybe
Why?
I didn't like all. And I
Okay.
didn't like A. Both those words just didn't really sound right to me when it came to that.
So you don't like the word all. Why?
Yeah.
Because
It's just too many. It's just
it's too many. It's impossible, right?
yeah.
It's impossible. Yes, that's right. And Justin, you chose D also. So I will stop here. Okay, yeah, the correct answer should be D. The reason, all possible, that's impossible. All possible sets of legitimate input. If you are asking the user to enter an integer, think about all the possible values of an integer. That's impossible to enter all of them, right? And all possible sets of inputs. The first one is all possible sets of legitimate inputs. Yes, that's impossible. Even for an int, you have so many, it's impossible. All prime numbers, that's impossible. It's limitless. All possible sets of inputs, that's impossible, because if you're asking for an int, if you want to test an integer, then you can enter a string, you can enter a question mark, you can, it's impossible. Useless, right? A single set of legitimate inputs, that's too little. One set of testing data is not enough. A reasonable set of legitimate inputs is correct. Yes, reasonable, not too many, not too few, so that you can know if your program works correctly. Okay, that's 2. 3. So you will do a midterm programming project, right? It's not just these small programs. Your midterm programming project, you will test your program, and that's when you will use a reasonable set of legitimate inputs to test to make sure it works correctly. Okay. 3. What must you use to create a multi-line string?
C.
C, you say C, a single pair of 3 consecutive double quotation marks. Okay, Caitlin, do you agree?
I don't know.
Yeah, okay. So
Question.
this is how it works, everybody. right? Let's look at this. You can do, what can you do? Print, right? Good morning. Multi-line, this is multi-line, and this works, right? And you can also use good morning. This is the new line, embedded new line characters. So both work. Any questions, everybody? Okay, that's number 3. Okay, number 4, what is used to begin an end of line comment?
B.
Who said that? Macreen? Macreen.
Yes.
Okay, you said B. Do you agree? Let me go on. Everybody, do you agree?
Yes.
Yes.
Yeah.
Okay, this is an easy one, right? Okay. Yes. Okay. Can you do? What do you see? Do you see yourself or do you see the other screen, the exercise?
I see the exercise.
Okay, good. I'm looking at you, so that's good. It shows the exercise. That's good. Oh, this way I cannot see the exercise. So that's B. Which of the following lists of operators is ordered by? Okay, you read it. Number 5.
C.
See? Anyone else?
For me, it just switched to your shell, so I can only see your shell.
Yeah, okay, this one. Number 5.
C.
See.
C.
Anyone else?
C.
C.
Okay, let me ask one more person. Amy, what do you say?
C.
C. Okay, very good. C. Yes, that's correct. Okay. Oops. C, right? Exponentiation, multiplication, and then addition. That's the correct precedence order, right? Okay. The expression Q evaluates to which of the following values?
B.
C.
A.
B.
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 A.
B.
B.
A.
It's B.
Okay.
If it's done left to right, there is nothing. 2 to the power of 3 is 8. 8 to the power of 2 is 64.
But
And,
it's done
Who
right
is
to left.
No, it's
It
9.
should be done right to left.
But wouldn't this
So
be like an exponent on top of an exponent?
Yeah,
so
you
it'd
would
be
do
like
the-
squaring
Yeah.
the 3, making that a 9, and then 2 squared, or 2 to the 9th power versus.
Yeah, you
know,
would take
2 to
the
3rd to the.
the highest exponent first. So like the 3 squared would be first, and then 2 to the result of 3 squared.
Oh, are you looking at that? Okay. When I look at you, I cannot look at the other screen. That's why I keep switching. Okay, you remember the exponentiation and assignment are right associative. Do you remember that? That means you go from the right first. Okay, so to go from the right, you will do 3 raised to the power of 2 first. That would be 9. And then 2 raised to the power of 9, that would be 512. Everybody, okay? And you are right. Most of you are right. Yes. So remember, this is right associative. That means you evaluate it from the right first. And also for assignment, it's right associative. You evaluate from the right first. Okay. Okay, the next one. The expression round evaluates to which of the following values?
A.
C.
C. C. C.
C.
Okay.
C.
Anyone else?
C.
You all agree with C? Why
Yes.
not A?
Because that would be it rounding down. Like that's
Yes.
just giving, yeah.
Like
Yeah,
the
this
little
is,
what they taught us in, like, I think middle school, like 5 or less, let it rest.
yes, yes. Okay, round up. Yeah, so C. Okay, 7. 8. Assume that the variable, okay, you read it and you tell me.
C.
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 C. Okay, you all agree, everybody?
Yes.
Yes, okay, C, 66. This is easy, right? It's a multiplication. Write an import statement that imports just the functions square root and log from the math module. How do you write that?
So it would be from math import square root, comma log.
Yes, very good. So from math import log and what else?
Square root.
Square root.
Okay, so that's how you do that. And now you can do square root. Right now you can use it. Okay, yes, very good. What is the purpose of the dir, directory function, and the help function? What is the purpose of dir? Are they the same? Oh, they are the same as in the book. What is the purpose of dir?
It gives you a list of all the I can't think of the word, the functions in the module, and then
yes.
help will let you know how to use those functions.
Yes, very good, very good. You answered those questions. I think that's all. Yeah, that's all, everybody. That is the that exercise, and there are no more exercises. Let's go back to our lecture notes. So I said that right now. Let's do these two exercises. We have about 20 minutes, and we can finish these two. Ask the user to enter a number. Use the square root function to get the square root and display it in a complete sentence. Ask the user for radius. You do this. Okay, let's do this. And this one we said we don't have to worry. And this is, so these are the last two exercises for this chapter. I will give you 15 minutes. Some of you may not need this at all, this much time at all, but to make sure everybody have a chance to finish it. Okay, let's do that. Okay, let's look at this. This is both of them. Ask the user to enter a number and you calculate the square root. That's what it says, right? Okay, let's look at the first one. You ask the user to enter a number and then you calculate the square root of that number, assign it to B, and then you print out the square root of your number is, you cast it to a string and concatenate it with a string and print it out. And then you ask the user for radius and you convert it to a float. Very good. And then you use the math.pi multiply by radius exponentiation symbol 2. And then you round it to 4 and then you print it out. Very, very good. Very good. That is the result, everybody. This is absolutely correct. Very good. Okay, thank you. Anyone else who wants to share if you did it differently, I like this formatting, okay. Num1 input enter a number and then you print out the number is very, very good. Very, very good, Jordan. I like this. Okay, then you do import from math import pi enter a number. And we cannot see the rest. You need to enlarge your screen. We cannot see the rest of the code. Yes, okay. Okay, and pi multiplied by a radius raised to the power of 2, and then round it to 4 places and convert. You are being very complicated, Jordan, right? Yes, this is correct. This is very, very good. You're doing this within one statement. Very good. I like it. And Yang's version is a little bit different. So, it's your own preference. Both are great. Both are correct. It's just one way or another. Okay, this is good. Let's run. Put it on the side so that everybody can see your code also, Jordan. More on the side. Okay. Okay. Yes. Okay. Okay. Until a radius. Yes, very, very good. Very good. The area of the circle with the radius. And you gave me a complete sentence. I like that. That's very good. Great work. Thank you, Jordan. Anyone else who did it differently? You use the function to calculate, the area. Anyone?
Oh, sure.
Okay. Omkar. Omkar and Justin, you are so good. You always want to share. You are so generous. I want to see if anyone else wants to share. Anyone
I can
else?
share if you want, man.
Share too.
Carlos, let's look at yours, Carlos. Yes.
Okay.
Oh, William and Carlos, both of you were talking. Who wanted to share?
Oh, that was me.
I don't. He had the first tip, so he can go first.
Ariel, William, and Carlos. Okay, let's look at Ariel's. Okay, so yes, square root, and then you did not concatenate the string. You used two separate items. That's the difference. And then the second one you did concatenate. Okay, very good, very good. I see this. This is the first string you did not concatenate. The second you did. Okay, good. Let's run. You run it. Okay, it's run. Everybody look at the output, right? Good. Thank you, William. Let's look at Carlos. Okay, so ask the user for input, and then you make it into the square root, and then round it to 3 and displayed it. Yes, very good. And then ask for that. Yes, this is what I was asking. You use look at the area of circle. CK, okay, it's equal to math.pi times math.pow. So this is what I was talking about. Use the math function. That's math.pow radius number comma 2. Raise the radius number to the power of 2. So what the first three versions are all correct. You can use the exponentiation operator, but think about it. Yeah, you can also use the math function, and this is the other version. That's what I was looking for. Okay, yes, very good. This is correct. Round it to the four decimal places and output it. Very good. Great work. Thank you,
Thank you.
all of you. Thank you, Carlos.